Okay, everyone, we're going to do differentiation, and we begin with the rules. First rule says dx of x to the power n equals n times x n minus 1. So, as you can see, the exponent was multiplied with the coefficient or the number in front, and then we subtract a minus 1. As simple as this, subtracting a minus 1. Okay, then number 2, is saying when we have dx this is now of two terms, f of x plus 1 minus g of x to equal dx of f of x plus or minus dx of g of x. Number 3. Number 3 is saying if we have now a constant which is k, with an f of x, it's like a variable, a constant with a variable. It's going to be k times ddx of f of x. You are separating the constant from the variable, but whatever you do to the variable, it's going to affect the constant depending on what it is. Because of the first rule, you're multiplying the exponent with the front of the variable. So number 4 is saying if we only have a constant, so ddx of a constant is equal to 0. K is our constant. So if we have an equation that we should differentiate, and it says ddx of a number, this can be 2, can be 3, can be 9, can be 10. If we're standing alone without the x, because we're only differentiating x over here, this will be 0. Whenever we differentiate a constant that's standing alone, it's a 0. Okay, now let us do an example. So our first example is going to be from our textbook, and the textbook is saying, it's giving us question 1 is y equals x to the power of 6. So according to the first rule, 2 dy dx equals 6 times x and 6 minus 1 equals 6x and 5. That's your answer. Number 2, y equals square root x dy dx equals, actually the first step we have to do here is this is the first thing you have to do, and you can't do anything if you don't do this. This is the first step. That is the first step. So it just makes it much more easier for you when you multiply and subtract. So half times x and half minus 1. Exactly the same step as this over here, as the first rule. So we write it as 1 over 2 x minus a half. Sometimes they will ask you to have your answer in a positive and a positive third. So how you write that is 1 over 2x and a half. This is positive exponent. And then for the positive third, or in third form, so this is positive exponent and third form and in positive third form where applicable, the question will state this. When they ask you to differentiate a question, they may ask you to leave it in a positive exponent and in third form where applicable. Then you have to do this. Then you have to do this over here. Okay. The next one is number 3. So number 3 is saying y equals 1 minus 1 over x minus 1 over x squared minus 1 over x to the power of 3. So, like over here, we have to make these not a fraction. We don't want a fraction and we don't want a third. So, what we're going to do is, we're going to say y equals 1 minus x minus 1 minus x minus 2 minus x minus 3. Now we can dy dx because it is in the form we wanted. Always put it in the form, in this form here. Always put in form so before you differentiate this at all, you must start here. You have to start there. Okay, now we can say dy dx of, so we know that this is a constant. So according to the rules, when we have a constant that's standing alone, it is equal to 0. So we can write a 0. Then over here we have a minus 1 times a negative 1. So this is positive x 1 minus 1 minus 1 is equal to, let's put it like this. Let's do it like this. So minus 2 times a negative 1 is positive 2x minus 2 minus 1. Minus 3 times negative 1 is a positive 3x minus 3 minus 1. This is the law. This is the first law, and you will use this law the most out of all of them. So now when you make this nice, it's going to look like x minus 2 plus 2x minus 3 plus 3x minus 4. And once again, when they say put it in positive exponent, we're going to simplify it and I write it like this. 2 over x3 plus 3 over x4. And that's the answer. Okay, next one. So the next one is saying question 4. So this is y equals 4x3 plus 2x squared minus 4x plus 3. Okay, so this is in the form we wanted. So we're going to start as follows. Dy dx equals to 3 times 4x 3 minus 1 plus 2 times 2x 2 minus 1 minus 4. This is a 1 here, as you all know. This is a 1 over here. So 4, 1 times 4 x 1 minus 1 plus 0. So what happened here? We multiplied the 3 to the front, the 2 to the front, and the 1 to the front. And we know the 3 now, it's standing alone. There's nothing that's with it, so it's equal to 0. Then with the exponents, we subtracted 1, subtracted 1, subtracted 1. Now we have to simplify it a bit more, and we say this is not 12x, 3 minus 1 is 2, plus 4x, 1. Then this is minus 4x to the power of 0, and that 0 falls away. So to make it a bit more nicer, we write it like this, 4x minus 4. Because we know anything to the power of 0 is 1, that means this x to the power of 0 becomes 1. And this is the answer. So now what I want to do is a few questions from an exam. So I'll do it in the red pen. So from exam, so what we are given is y equals x over 2 plus 2 over this is the fourth root of x. So as we now know, you don't want a fraction. Let me write this on the side. Don't want a fraction. Don't want a fraction. So simplify. This is equal. You don't want a fraction and you don't want a square root or a fourth root even. So how do we write this? We write 1 over 2 x 1 over 2 plus 2 x 1 over 4, and it's a minus. It's a minus because it's under, and we all know that when you bring a exponent to the top of a fraction, the sign changes. So now we write it. Now we can do the rule itself. And the rule is saying 1 over 2 multiplied the exponent x 1 over 2 minus 1 plus minus 1 over 4 times 2 x minus 1 over 4 minus 1 equal. What happened now? So what happened now is we multiplied to the front, and we multiplied to the front, then we subtract 1 and we subtract 1. This is the rule. You've been doing this rule for the past few questions. You will always do this. So now we have to multiply everything together. This is 1 over 4 x, this is minus a half, then 2 times 2 times minus 1 over 4 is minus a half, x minus 1 over 4 minus 1 equal minus 5 over 4. So now we make it nice and we say 1 over 4 x minus 1 over 2 . That's your answer. This is dy dx. So we're doing this because they will say leave it in positive exponent and third form. Always we will do this. Always we will use this law. This one we will always use. Multiply the exponent with the front of the number and then we minus 1 from the exponent itself. Always. Okay, let's do another one. So this one I have here is saying, the one I have here, one second, the one I have here is saying, it is saying y equals 1 over x plus 2 square root x minus 1 over square root x. So when we get an equation like this, we must say for ourselves, we don't want fractions and surds. You don't want fractions and surds. So if we don't want it, we must simplify. Y equals x to the power minus 1 plus 2x 1 over 2 minus x minus 1 over 2. There you go. So now it's in the form we want. It's in the form we want. You always want it in this form. Just makes your job much more easier. Now we can say dy dx equals exponent times the front, which is a 1, minus 1x, the exponent minus 1, half times the front number, and then the exponent minus 1. Then the exponent multiplied the front number, which is a minus 1, so we say minus 1x minus half the exponent itself minus 1. So now we just simplifying it nicer, so minus x minus 2 plus x minus a half minus x, I believe this is 3 over 2, minus 3 over 2. So what we do now is, the question will always most likely state to leave it in positive exponent and surds where applicable. So when we do that, we don't worry, because we not do that by now. So we write 1 over x to the power of 2 plus 1 over square root x minus 1 over x to the power of 3 square root 2. And that's the answer. So again, this is leave exponents C2 and surds where we applicable. And that's the answer. That's the answer. Always it will be like this. Always. No matter what, in the exam, in the test 2 even, when you get an equation, you don't want fractions and surds, so you simplify it. Then you do the first rule, where you multiply the exponent with the front number, and then you subtract 1 from that number, from the exponent itself. Always, no matter what, it will follow like this. Also, the question will add to leave the exponents positive and put in third form where applicable, like over here and over here. Again, the question will state to leave your answer in a positive exponent and to put it in third form where applicable. This is in third form. So now to convert these answers here and over here into third form, because it's very important and you will lose marks if you don't do that. Let us do one more. So this last question is saying y equals square root x plus x over 3 minus 2 pi. So again, top one fractions, time to fractions, and thirds. When you're starting an equation, you don't want fractions or thirds ever with differentiation. So we simplify this and then we say x is 1 over 2 plus 1 over 3 x minus 2 pi. So this is the form we want. Now we can say dy dx of this equation is equal to the exponent times the front of the number of the coefficient is half x, and then the exponent minus 1. Then we know that there's no exponent here right now, but we know that it's a 1. So 1 times 1 over 3 is 1 over 3 x, the exponent minus 1. And then we must pay attention to seeing that there is no x with this minus 2 pi. So this minus 2 pi is the coefficient, not the coefficient, the constant. This is a constant. Let me write this. This is a constant. Also to note, it's alone. And by now we must know that when it's alone, it's a 0. It's equal to 0 because of this law right here. It's equal to 0. So now we're just making it nicer, and we're going to 1 over 2 x, half minus 1 is minus the half, plus 1 over 3 x to the power 1 minus 1 is 0. And let's do it like this. So I'm just doing this so everyone, I want to make sure everyone knows that x to the power 0 is 1. That means it's this. That means it's written like that. So let's simplify this even more, because once again the exponent is negative and we can put this into third form. So we're going to do that by, we're saying 1 over 2 x, like that, plus 1 over 3. There you go. That's the answer. Just a very important note is to leave or to convert this. Very important. You have to convert that into positive exponent into third form where applicable, because you will lose marks for not doing that. everything we did now, all the steps following up to this, is all you need to know for N3, for N3 differentiation. So if you can do all of these, you can do N differentiation in your textbook. Okay.